Welcome to Advanced Data Analysis 2 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. This is the second part for worksheet number 1 in our class. So we were just about to go to UNM Learn to answer these quiz questions. So I'll go over to the browser and log in to Learn. Go to our, oops, that's not our class. And go to the in-class assignments. All right, so I'm going to click on this multiple choice. And I will say that there was a mistake earlier in the day where these questions were in the wrong order, and I've just fixed that. That was the purpose of breaking the video into parts. So here's question 1. What's the lowest recorded punting distance among the 13 participants? And so we want to look at lowest recorded punting distance, and this is really the average, their average. So punting distance, the lowest one. So if I go back to R, here is distance, and here's the minimum. So 104.9. 104.9, looks like B is the correct answer right here. Yeah. And UNM Learn automatically saves those answers for us. Now I'm going to show you something else that you can do. All right. So I do have a comment here. Note that you can do even better than reading the numbers from above to answer the specific quiz questions. Instead, you can write code that returns the specific values you want. So let me go over to R. And notice all that output is just from these two lines, summary punt and apply. Here the apply function is over the data set punt. I'm producing a table, a frequency table, and the number 2 here indicates which dimension I'm applying the table function. So 1 would be rows and 2's are column. 2 is a column. So for each column, in the punt data frame, I'm going to perform a frequency table. That's what the apply function does. And so here you can see, if I scroll up to the top of that, here's the apply function. And so here's distance and all of the unique values for distance and what their frequency is. Okay? A lot of these are going to be unique because they're numbers. Here we've got strength, 110, 120, 130. Okay, these are rounded to the nearest tens, and so we do have multiple instances of 2 observations of 160 and 3 observations for 170, and so on. All right. So yeah, do beware. Some lines of code can produce a lot of output. All right. And then I have this comment that I just read to you, that we can write code to produce the actual numbers we want. So I can write the minimum distance is, and here's a function, the minimum of punt $distance. Now punt $distance, okay, so I'm going to take this one step at a time. Punt, I'm going to highlight punt as I just did and press Control Enter, and down below it's going to print out the 13 lines and the header of the punt data frame. All right, punt $distance, a dollar sign is one way to reference columns. So if I highlight punt $distance and press Enter, I should get the same list of numbers that are under this left-hand column under distance. So I'll go ahead and press Control Enter. There's punt distance, and you can see the last 2 values, 150.17 and 165.17, are these 2 last values right there. Okay, so I've gotten that column. Min reports what the minimum value is, 104.93. Was that our answer? Yes, that was our answer. Okay, good. And then one of the beautiful things about Markdown is that I can include this in a sentence. So I use one left tick at the beginning and one left tick at the end, and if I start that with R space, it will interpret anything after that using R. So this one command gets interpreted by R. And if I go back to the web page, here's what it shows. Star, the minimum distance is 104.93 feet. And that number, 104.93, is being calculated from the data. This is amazing, right? Because this means that you can write sentences with numbers in them, and if you, at some point later, change the data and recompile, all those numbers are currently up to date. All right. So what's the second question? I'll just write another example. What's the highest recorded hang time? Okay, so let's do the same thing, but for the maximum hang time. So I'm going to copy and paste what I've already got. So the maximum hang is R max, and then I just need the variable hang, and I believe that's correct. Capital hang. There it is. So if I recompile by clicking knit, it saves the document, recompiles it, produces the output, and here is the additional line. The maximum hang is 4.75. Now, it's almost just as quick to write these lines of code as I did, as it is to scroll up and down and find hang, max. No, that wasn't that slow. But the point is that it's not hard, right? Okay, those are not necessary. I do say that's not required. Okay, but it's just a way of showing you what a wonderful tool we have. All right, plotting. This will be new for some of you. So plot y equals distance and x equals hang. It's maybe even a little easier to read over here. Not really. Y is distance, x is hang, and interpret the plot in terms of linearity and strength of the correlation. All right, and I have a code chunk here that is intended to get you started plotting something using ggplot. What if you've never used ggplot? You can use the standard plot functions. So we could actually just do plot. We've got, and there's 3 ways to do this that I can think of off the top of my head. If I do question mark plot, that opens up in the help window the help for plot, and you can either use plot x and y. There's also a way to use functional syntax for this, but I think I'll just keep it simple just for a quick and dirty. Okay, so plot x first and then y second. Okay, so I wanted x to be the hang, so that is punt $hang, and then the y is punt distance. And I want to show you something also. All right, I just typed PUN and an autocomplete came up. It gave 3 options, and punt is what I want. So I'm just going to press the tab key. I'm not going to use my mouse. That's slow and clumsy. I'm just going to press tab and it will autocomplete. $. Notice it gives all the options for what's inside punt. Distance is already highlighted. I'm just going to press tab and it fills it in. All right, close parentheses. I'm going to press Control Enter, and in my plots window down here, the plot will appear. Okay, that is a totally acceptable plot for this assignment. If you want it to look even nicer than that, you can use ggplot, where we assign aesthetics and layer data and summaries. So in this case, I'm using ggplot. Now it does require a library, so you have to run library ggplot2, and now I have access to the functions within ggplot. So here's ggplot. I specify the data frame. Why don't I just bring up the help for this. Help ggplot. And there isn't going to be a lot of help in here for ggplot that's that easy to use, unfortunately. There's a little bit of a learning curve, and we covered a lot of that last semester. There are tons of examples, however, but let me sort of get you started. So x here is hang, y is distance. So we are encoding these two variables, distance and hang, as the axes of this plot. And all those encodings happen under aesthetics, AES. And if I just run these two lines and press enter, we will have a disappointing result because I haven't told it what to plot yet. There's no objects plotted yet. I haven't told it to plot points or box plots or text or anything. And for some reason it's hanging there. Alright, what happens if it hangs? You can wait. You can press the escape key to see if it stops. And I've pressed it now about 15 times. Sometimes there's a red stop sign somewhere that you can click to stop. But I don't see it right now. I've even tried to save this document and it hasn't saved it. We haven't really lost a lot of work. And if you are recording a video and time is of the essence, you can just kill it. Sure, let's try to save those. Seems like it doesn't want to work. We can say don't save. I can bring up the nuclear option and kill it. Alright, my computer's been through a lot today. Alright, let's bring up back our studio. And we'll need to, oh, sorry about that. We'll have to resize it to fit in your window. All right, talking about ggplot. So there's tons of examples in the course notes for ggplot. I think I do almost every plot in ggplot, except for sort of specialized plots. All right, so I'm back where I was. In fact, looks like it probably auto-saved. So we have it. We didn't lose anything but typing those distance and hang in there. Great. So let's get started again. X is hang, Y is distance, and my environment is currently empty. I'll need to go back up and reread in the dataset. Okay, reset the working directory, load in punt, there's the structure. All right, there's a plot of the data. Okay, so let's use ggplot. I'm going to run these three lines. It's going to load the ggplot library, and then set the axes, X and Y, and then print it. And you can see down here, beautiful, right? Hang, distance. Now we need to assign some points in the middle. So we're going to create a layer. So when I ran ggplot, I assigned that into P. So P includes the axes right now. Now we're going to add layers. So we're going to update P by starting with P and adding to that something. And this is what I would do if I were you. I'd go to the course website and I would go to some notes. How about chapter 1? Open up the PDF file. Page down until I see the sort of plot that I'm looking for. Let's see, a scatter plot's going to be in chapter 8 from last semester. So I'm going to jump to the very bottom and then page up. All right, so here's a plot. It's got a bunch of extra junk on it. It's got a line. It's got some labels on it. We don't really need any of that stuff, but we do want this part. Geom point. Okay, that's the geometric object that puts points on there. Now, when you copy and paste from a PDF file, you may get extra junk. So I'm just going to give it a shot and see what happens. But if it doesn't work, that is one of the reasons I also include the R files. So you can always open up the R code file Okay, I'm going to page all the way down to the bottom, scroll up until I see something like this. Okay, so there's, I'm zooming in and then finding it again. Okay, there's the code. And so I can copy and paste from this because there's nothing special here. Sometimes in PDF files there's what looks like white space turns out to be something else in there, and those characters don't interpret well inside R. All right, so there's my plot. Let me go back to my question.